Consider this function, 3x plus 2 over x squared minus 5x plus 6. Find the asymptotes. So first of all, the vertical asymptotes. Vertical asymptotes are when the denominator, in this case x squared minus 5x plus 6, is equal to 0. It's a quadratic equation, so we need to solve a quadratic equation. We're going to do that by factorizing. Multiply to make 6. It's going to be minus 2 and minus 3, which means we have two vertical asymptotes, x equals 2 and x equals 3. Horizontal asymptote. Now we either remember the result for a linear over a quadratic, or we think as x tends to infinity, what happens? As x tends to infinity, y is tending to 3x over x squared, because they're the most sort of important terms in each of the parts. But that is 3 over x, which tends to 0. So our horizontal asymptote is y equals 0. The coordinates of the axis intercepts, let's do the y-intercept first. That is when x is equal to 0. So we get y is equal to 2 over 6, because all the x bits cancel out, so that's 1/3, which means our y-intercept is 0, 1/3. Roots are when y is equal to 0, which means we have 3x plus 2 over x squared minus 5x plus 6 is equal to 0, which is only true when 3x plus 2 is equal to 0. So x is equal to minus 2/3. So our root is minus 2/3, 0. Now with all that information, we are going to sketch what the graph of this function looks like. I'm going to start by drawing out a big set of axes for this graph. And then we're going to look at the asymptotes first. So my vertical asymptotes were 2 and 3, so coming back down here, at x equals 2, and at x equals 3, I've got vertical asymptotes. I've also got a horizontal asymptote. The horizontal asymptote is at y equals 0, which is my axis here. Now I'm going to look at the intercepts. I have a y-intercept at 0, 1/3, so about here. And I have a root at minus 2/3, so about here. Now I can start to put this together. Well, this left-hand one, we can think about what this is going to look like. But actually there's a little trick here. So we're going to have to do a sign diagram, essentially. So my function, remind myself of my function, originally was 3x plus 2 over x squared minus 5x plus 6. Now let's think about what happens in each section between different parts. So let's start over here first, on the far right hand, so bigger than 3. When we're bigger than 3, let's use 10 for example. I get 30 plus 2, that's positive. 100 minus 50 plus 6 is also positive. So this section here is always going to be positive, which means it's got to approach that asymptote, and it's got to approach that asymptote there. In the middle of 2 and 3, let's do 2.5. I'm going to get 3 times 2.5 is 7.5 plus 2 is positive. So this is going to be positive. Over, and then 2.5. 2.5 squared, 2.5 times 2.5, minus 5 lots of 2.5. Well, that's more negative. So that's going to be negative, plus 6. That, to me, I'm pretty sure is going to be negative. I am actually going to just double check that. 2.5 squared minus 5 times 2.5 plus 6 is indeed negative. Only just negative, but it is negative. So we've got a positive over a negative, which means this whole thing is negative. Given there's no roots in this section, the whole bit in between here has to be negative, and it has to approach these two asymptotes. So this is going to come up something like this, and then at some point it's going to turn around and do something like this. It's very narrow, very long, and very thin. Now what about on this side? Well, we can see that here we know roughly what's going to happen, because it's got to come to this point, it's got to go up to there, and then over here it's got to go up to that asymptote. But it's meant to be going towards this asymptote, so what's happening here? So let's think again about the sign diagram after minus 2/3. So let's do something like minus 1. At minus 1, we have minus 3 plus 2, so that's negative, over, at minus 1 we have 1 plus 5 plus 6, so that's positive. So over this side it's negative. And what that means is this graph is going to come down, but it has to approach this asymptote. So at some point it's going to bend back up and then approach the asymptote like that. It never crosses again, it never reaches asymptote, but it does get closer and closer to it. So at some point it stops going down and starts coming back up again, and there's this point here where it does that. We don't know where that is. We will see methods to do that when we do calculus, but we don't know for now where that is. But we know that it has to do that because it has to approach this asymptote. So here we have a slightly more complicated one of these linears over quadratics, because there's different bits going on and they're a bit harder to work out what's happening. But hopefully you understood there the reasoning I went through for why they were in each of those different sections. You could be asked to sketch something like this without a calculator, in which case you would have to do this kind of process, finding the asymptotes and finding the roots and the y-intercept. These kind of ones, that's unusual when it's this kind of difficulty, but it could happen. It's worth thinking about a few more different types. If you go back to the investigation that we did at the beginning of this little section, you can see some of the different shapes you get out of these linear over quadratics. You could also just open up your calculator and try typing different linear over quadratic functions to see all the different shapes you can get out of these kinds of functions, because they can look quite different. They generally have 3 parts, but the 3 parts don't always look exactly the same.